Assalamu alaikum. I am Nadia Islam Konika, ID 123080022. My today's presentation topic is about flop, RS flip-flop and JK flip-flop. What is flip-flop? A flip-flop is a basic electronic device used in digital electronics to store a single bit of data. It acts as a memory element by maintaining one of two stable states, representing either a 0 or a 1. Since a flip-flop is a sequential circuit, its output depends on both the current input and the previous output state. It has two inputs which are always complementary to each other. A flip-flop can exist in one of two stable states representing either a 0 or a 1. Types of flip-flops. There are four types of flip-flops. These are RS flip-flops, JK flip-flops, D flip-flops, and T flip-flops. RS flip-flop. What is RS flip-flop? The RS flip-flop is used to store a single bit of binary data, either 0 or 1. It has two inputs, set and reset. Here S stands for set and R stands for reset. When both inputs are inactive, the flip-flop maintains in current state. Activating the set input switches the flip-flop to the 1 state, while activating the reset input switches it to the 0 state. Construction of RS flip-flop. The RS flip-flop can be constructed in two common ways: by using two NOR gates along with two NAND gates, and by using an configuration of four NAND gates. Figure 5.5 is using two NOR gates and other one is using four NAND gates. Basic block diagram of RS flip-flop. The basic block diagram contains R and S inputs, and between them is clock pulse. Q and Q prime is the complemented outputs. RS flip-flop circuit with NOR gates. As we can say that before, RS flip-flop can be constructed with two types of gates. In figure 5.5, an RS flip-flop containing two NOR gates has been illustrated. It should be recommended about NOR gate that its output is 1 only when all of its inputs are 0, and when any one or both of the NOR gates inputs are 1, its input is 0. Types 1. When both inputs are 0, that is R equals 0 and S equals 0, the NOR gate's inputs do not affect the output. As long as this input condition remain unchanged, the flip-flop maintains its current state. No change occurs in the input queue. This behavior corresponds to the third line of the truth table when the flip-flop stays in its previous or normal state. If the S input becomes 1 even momentarily, the flip-flop transition to the set state. Conversely, if the R input briefly becomes 1, the flip-flop moves to the reset or clear state. Type 2. When value of R is 0 and value of S is 1, in such a situation, output of the bottom NOR gate becomes 0 or low, as output of bottom gate is also an input of the top gate. In this way, bottom inputs of the top gate becomes 0 or low. Resultantly, output of the top gate becomes high or 1, such as flip-flop sets when inputs S becomes 1. Remember that when flip-flop's output Q is 1, that is Q equal 1, is stable state of flip-flop is called set. This has been demonstrated fourth line of truth table. Type 3. When our input is 1 and S input is 0, that is R equal 1 and S equals 0, the output value of top NOR gate becomes 0 or low. As input of top gate is an input of the bottom gate, hence both inputs of the bottom gate become 0 or low. As a result, high input is obtained from bottom gate. Therefore, applying 1 on input, flip-flop reset on a stable state, which is known as a clear state or reset state. When both inputs are 1, a forbidden state prevails on flip-flop. As a result, output of both NOR gates becomes 0 or low. In other words, value of Q and Q become identical or same. As this thing is absolutely opposite to the rudimentary definition of a flip-flop. Remember that as per basic definition of a flip-flop, both in outputs of a flip-flop are commonly inverted or opposite. Therefore, under normal circumstances, both flip-flop inputs do not become one simultaneously. If such a situation arises, state of output Q become indeterminate or indescribable. This condition is occasionally represented in a truth table by a question mark. RS flip-flop circuit with NAND gates. The behavior of NAND gates is important to understand. When both inputs are 1, the output becomes 0, meaning the state change. However, it's either 1 or both inputs are 0. The output remains 1 or high. This characteristic response defines how NAND gates operate. Types 1 operation. When both inputs are 0, the output of the flip-flop both becomes 1. This condition is known as forbidden or invalid state. During normal operation, flip-flops are never designed to function in this state, as shown in the truth table. Type 2, as shown in the fourth line of the truth table, when the S input is 0 and the R input is 1, the output Q become logic 0, while Q complement become logic 1. As a result, the flip-flop enters the reset condition, meaning it is cleared to 0. Type 3, when S input is 1 and R input is 0, output Q becomes reset, that is, it sets on 0. This condition is known as clear state. In type 4, when both inputs are 1, in such a situation, both outputs retreat on to its previous or last condition. Resultantly, no change substantiates. This condition of any flip-flop is known as a hold condition. It has been exemplified through line number 4 of the truth table. Clocked RS flip-flop. The clocked flip-flop uses two AND gates A and B as the input. Stage and common input of both AND gates is named as clock CLK. These two AND gates will supply an input S and R to RS to operate when and only when CLK is high. If clock is low, using an don't care condition of AND gate, R and S input becomes 0 or disabled to provide input to RS. JK flip-flop. What is JK flip-flop? A JK flip-flop is a type of bistable multi-vibrator, a digital memory circuit that has two stable states and is used to store one bit of data. It is an improvement over the RS reset set flip-flop, eliminating the problem of the undefined state when both inputs are high. JK flip-flop inputs and outputs. Inputs J set K reset. In clock CLK synchronized changes. Sometimes preset and clear. Output Q current state and Q prime inverse of the current state. The JK flip-flop is one of the most commonly used and versatile types on flip-flops, often referred to as a universal flip-flop due to its wide range of applications. The two inputs, level J and K, are not abbreviations like S for set or R for reset. Instead, they are standalone ladders selected by the flip-flop's inventor. The sequential operation of the JK flip-flop is exactly the same as for the previous RS flip-flop with the same reset and set inputs. The difference this time is that the JK flip-flop has no invalid or forbidden input state of the RS even when R and S are both logic 1. The JK flip-flop is initially an enhanced version of the gated RS flip-flop with an added clock input which eliminates the invalid state which occurs when both R and S are set to logic level 1. Thanks to this clocking mechanism, the JK flip-flop supports four distinct input conditions: set, reset, no change, and toggle. It circuit symbol closely of an RS bistable latch, with the key difference being the inclusion of a clock input of controlled operation. The basic JK flip-flop. Both the R and S inputs of the previous RS bistable have now been replaced by two inputs called the J and K inputs, where J is equal S and K is equal R. The two input and gates of the gate RS bistable have now been replaced by two three input NAND and gates, with the third input of each gate connected to the output at Q and Q complement. This cross coupling of the RS flip-flop allows the previously invalid condition of S is 0, 1 and R is 1 state to be used to produce a toggle action as the two inputs are now interlocked. If the circuit is now set and the J input is inhibited by the 0 status of Q through the lower NAND gate. If the circuit is reset, the K input is inhibited by the 0 status of Q through the upper NAND gate. As Q and Q are always different, we can use them to control the input. When both inputs J and K are equal to logic 1, the JK flip-flop toggles as shown in the following truth table. Here is the truth table for the JK function. Although the Jacket flip-flop offers improvements over the clock RS flip-flop, it can still encounter timing issue known as a race condition. This occurs when the output queue changes state before the clock pulse has fully turned off. To prevent this, the clock pulse duration T must be kept very short, meaning it should operate at a high frequency. However, achieving such short pulse can be difficult with JK flip-flops built from basic NAND or NOR gates. To overcome this limitation, more reliable and stable design like master solve edge-triggered flip-flops were introduced. Thank you, everyone.